In section 7.1b, we're going to talk about multiplying and dividing rational expressions. We're going to split it up into multiplication and division, but we're also going to split it into types. Now, before we start that, though, I want to just talk about how we multiply fractions without the added difficulty of the variables to it. So the example I'm giving you right now is 25 over 14 times 21 over 55. The first thing I want us to do is I want us to reduce the fractions. And remember, as long as it's from top to bottom, we can reduce it. It can be in the same fraction or it can be across fractions. So you'll notice that 25 and 55 are both divisible by 5. So we're going to divide out of 5. That makes this 5 and that makes 55 11. 14 and 21 are both divisible by 7. So that makes this a 2, makes the 21 a 3. So real quick, and this is going to help you when we're doing the more complex problems, I'm going to go ahead and rewrite what's left over. So we've got 5 divided by 2 times 3 over 11. Okay, and then you want to take just a real quick look and make sure that you didn't miss anything or didn't cancel out the highest thing. It looks like we're pretty good here. So the last thing we're going to do is we're just going to multiply across. Okay, and we're going to get 5 times 3, which is 15. And 2 times 11, which is 22. And since we reduced it to as our step 1, then our final answer is in its most reduced format. Okay, so our first example that has letters in it here, we've got 5m cubed over 2 times 6 over m cubed. And what we're going to do is we're going to do the same steps we did in our example with just the numbers. We're going to first start by reducing. Remember, when you're reducing fractions or with fractions with letters in them, we subtract the exponents. So here with our m cubed, on the top and on the bottom, they would actually completely cancel each other out since they're the same amount. The other thing we can find is that we've got the 6 and the 2 here that would reduce. This 2 would become a 1. The 6 would become a 3. So if we rewrite this, we've got 5 over 1 times 3 over 1. Since we got rid of that m cubed on the bottom of that second fraction, the only thing left is a 1. Now if we multiply straight across, we've got 15 over 1. And we don't want to put the over 1 as our answer. We just want to say that our answer is 15. So for our second example, we have 24y squared divided by 5x times 15x over 6y. And we're just going to start reducing with the 24. We'll notice that 24 and 6 are both divisible by 6. So 24 divided by 6 would give us 4. And 6 divided by 6 would give us 1. Now we've got 2 y's on the top and 1 on the bottom. That means that if we cancel out a y on the top, we would have just 1 left. And the y on the bottom would go completely away. Okay, notice 15 and 5 are both divisible by 5, so the 15 becomes a 3, and the 5 becomes a 1. Also, there's an x on the top and an x on the bottom. That means that they would cancel each other out. And now let's see what we got left over here. We've got 4y over 1 times 3 over 1. Okay, and we'll multiply straight across on both top and bottom. We're going to get 12y over 1. And again, we don't want to put the over 1, so we're just going to say our answer is 12y. So for our last example of this type, we've got 2m squared over 5n squared and 15m over 8n. Okay, so let's start with a 2 and let's see what we can do here. Notice that 2 and 8 are both divisible by 2, so the 2 would become a 1 and the 8 would become a 4. And notice your m's are both on the top, so we can't cancel those. 15 and 5 again have a 5 in common, so the 5 would become a 1. 15 would be a 3. And again, notice your n's are both on the bottom, so we can't cancel those as well. So right now we've got 1m squared over 1n squared times 3m over 4n. And we're going to multiply straight across. So that is going to give us 3m cubed. Remember when you're multiplying variables together that you add those exponents, and that exponent on that m is a 1, so that's where we're getting that 3. Same thing on the bottom, multiply straight across, which would give us 4n cubed. And there is our final answer. Okay, so for the steps of multiplying these rational expressions that have only multiplication in them, there's no addition or subtraction, which we'll talk about here in just a minute, are number 1, you're going to reduce from top to bottom. And remember, it doesn't have to be in the other fractions. It can be in the same fraction that you reduce. The second thing you're going to do is you're going to rewrite it just so you can see what's left over and see if you might have missed something when you were looking at what could reduce. And the third step is you're going to multiply straight across. And you are done. Okay, so now we're going to start doing multiplication, but we're going to add in addition and subtraction as part of the problem. Now what you have to remember is anytime you see something added or subtracted, you kind of have to think of it as one thing, or if it's married. And the only way we can cancel something that's added or subtracted is if it has the exact same thing on the top or bottom of the fraction. Okay? So the example I've got here for you for number 4 is 8 minus m over 3 times 4 over 5 times m minus 8. You'll notice that the m minus 8 and the 8 minus m are really, really close, but they're not quite the same thing. What's making them not the same is the fact that the 8 minus m is backwards. So what we're going to do is we're going to use the power of -1, okay? And we're going to take and we're going to multiply the top and bottom of our first fraction by -1, because that's going to cause our m and our 8 to switch signs, okay? So top and bottom by -1. We're going to have -8 plus m over -3. And all we're going to do next is just rewrite this so that the m comes first. And we're just going to say this is m minus 8 over -3. And remember that that m minus 8 is one thing. Now you're going to bring down that second fraction. Okay. And notice now that our m minus 8s are exactly the same. We can cross those out as one piece. And what we're left with is 4 over -15. Now we don't ever like to put our negatives in the bottom of a fraction, so what we're going to do is just take that negative and switch it up there to the top and make this -4 over a +15. And there's our answer. Okay, so for our next example, we've got 6b minus b squared over 2a times 3a squared over 4 times b squared minus 36. And you'll notice, similar to the first one, the top of that first fraction is backwards. It's got the negative b squared. And we actually want to try to have our higher exponents in the front. And what we want to do is, again, change the signs of the 6b and the negative b squared. So we're going to multiply top and bottom again by -1. So that's going to give us a -6b plus b squared over -2a. And then we're going to switch these two around to put that b squared first over -2a and bring down our second fraction, 3a squared over 4 times b squared minus 36. Now, unlike the last one where we just got to cancel after that, this one we're actually going to have to do some factoring on. If you look at the top of the first fraction, you'll notice that there's a b in common with both b squared and 6b. So we're going to pull a b out, and we'll get left b minus 6 over negative 2a times 3a squared over. Now that 4 is going to just come down, but notice that b squared minus 36, that's a difference of squares. So we're going to factor that into two parentheses. It's going to be b plus 6 and b minus 6. Once we get everything factored, then we can start going through and canceling. Remember, if it's more than one term of addition and subtraction in there, they have to be exactly the same. So we can do the b minus 6 and the b minus 6. We can also cancel one of the a's out. So this a on the bottom would go away. That would just become a single a. Okay, go ahead and rewrite it just in case we miss something. So we've got b over negative 2 times 3a over 4 times b plus 6. If we multiply straight across on the top, we're going to have 3ab. On the bottom, we're going to have negative 8 times b plus 6. And again, just like the other problem, we don't ever want to have a negative on the bottom, so we want to move that negative up to the top. And our final answer would be negative 3ab over 8 times b plus 6. So for our next example, we have 5 over r plus 2 times 3 times r cubed plus 2r squared over 23. Okay, we can't do anything as far as factoring in that first fraction, so we're just going to write them down. 5 over r plus 2 times. Now, on the top of this second fraction, it's like somebody's done half the job for you. They've taken a 3 out, but they missed the fact that both of these two terms in the parentheses have r squared in common. So you're going to leave the 3 alone. He's going to just bring down, and you're going to take an r squared out of that parentheses. Then you have r cubed. That leaves us 1r plus 2 over 23. Now what we can do is cancel the r plus 2's out. Well, we're going to multiply straight across here and get 15r squared over 23. And there's our answer. So for our last example for multiplication, we've got y squared minus 4y plus 3 over y plus 10 times y plus 10 over y squared plus 5y minus 6. So the first thing we want to do is go ahead and factor everything we possibly can. So on the top here, we're going to factor this to y minus 3 and y minus 1. Okay, on the bottom we can't factor y plus 10, we're going to leave that alone, times, we've got y plus 10. On the bottom here we're going to have y plus 6 times y minus 1. And then we can start canceling. We've got y minus 1 is exactly the same. And we've got a y plus 10 that we can cancel. So that's going to leave us on the top y minus 3. And on the bottom y plus 6. Okay, so for the basic steps of multiplying rational expressions when there is addition and subtraction within the problem, step number 1 will be to factor anything that you can possibly factor, whether you're taking out a GCF or if you're going into two parentheses. Step number 2 is to cancel anything that's alike. And step number 3 is to multiply straight across.